Hello, happy Valentine's Day from Seattle. It's Valentine's Day 2021. We got some snow and it is the typical northwest wet slushy snow, and I want to use this right away as a physics experiment and measure the density of that typical wet snow that we get here for our load assessments. For our collection, I prepared here a large bowl. It's a cooking scale. It's set to newtons, and I just reset it to 0 so we don't have to worry about the weight of the bowl before we go outside and collect some snow. Okay, we are out in the driveway, and this is the area where the snow nicely collected over the last 3 days. And I'm going to create a specimen that we can then extract and weigh. Okay, so I used my avalanche gear to create a specimen as close as possible to a 1-to-1 foot square. Let's now get dimensions before we extract it. This is my snow specimen. The important part is to not change the density by compacting it before we get the dimensions. So what I did was I tried to very carefully extract snow all around without actually touching the specimen itself. We call this an undisturbed sample, and undisturbed is always as good as it gets. Let's first measure the height of the specimen, and we see here I'm at the corner. I get one corner. I measure the next corner so we can account for errors and irregularities later. I measure the third corner. We see this one's a little bit harder to even see where exactly the snow is. I leave that a little bit to your imagination. And we measure the fourth corner. And we see here that one's actually easier to read. That's our thickness, snow thickness. I just want to verify as well that my dimensions are reasonably accurate. See here, 12 inches. That's the other side, 12 inches. That is now rotated. We got 12 inches. And we have the other side. And that's a tiny bit actually less than 12, but I would say this is possibly close enough. So we have now the thickness and the dimension. Means we have the volume of the undisturbed snow sample. The last step is we try to collect the snow sample. I try to get the entire sample into my bowl, but not any of the surrounding snow. At this point, it does no longer matter if I disturb it in shape or if I compact it. So I hope we can fit it all into our bowl so we can get our measurement done. It looks like it's gonna be a little bit challenging. It's a bit too much at once, just for compacting, because I don't want to lose any snow here on the side or we start all over again, which we may almost get there. So that was what just fell on there. Okay, if Professor Adorino from our geotech section sees that, he sends me right away back out and lets me redo it for being so sloppy. But I think it's gonna be accurate enough for what we are trying to achieve, and that is a reasonable value for snow density here in Seattle. And I'm gonna need my hands here to finish that. Okay, here is my compacted snow sample. We can actually now take this and go back inside into the worm. You see, I picked up as good as I could. We have the sample, back to the scale. Okay, we are back inside in the worm. I got everything back on the scale again. Remember, the scale was calibrated, so it was 0 at the weight of the ball. So what we are measuring here is really the weight of the snow. We have the snow here as 22.0313 newtons. I wouldn't give too much about the last few digits. That's the accuracy of the scale already. For everybody who wants to get mass density and not just specific weight, reminder, we are here in Seattle at sea level, so standard gravity.